All right, 6.2, sorry, 6.3. This is second video, and I'm gonna do two examples here, and that'll be enough. All right. So this is number 6, and it's page 3.381. Okay. So I need to find the solution of this linear differential equation system, right? So here, again, this is your A matrix. So I'm gonna find out what is the eigenvalue and eigenvectors, right? So what I'm gonna find the determinant of A minus lambda I. So do that, and then I found the eigenvalues plus minus 2i. So this is a complex eigenvalue, right? So complex eigenvalue, that means I'm gonna get complex eigenvector. All right. So I forgot to tell you last video. So our goal is to write down our eigenvector in terms of a real term, right? That's what we are doing here. Again, now after you get the eigenvalues, so I need to find the eigenvectors. So what I'm gonna do is, again, A minus lambda I, find that matrix, and change that matrix into row echelon form. Again, this term I have to be 1, so divide by 2 minus 2i, divide them, that's going to be 1. And then again, you divide here, this row, so you're going to have like that. And when you multiply this first row by 2 and then subtract, you're going to get 0 here, and then the same way you're going to get 0 here. I do it here, this problem here. How do I get 0? Okay, just check this one. Because you multiply this one by -2 and add it, all right? Or multiply by 2 and subtract. Or so I multiply by -2, that makes it -8. Or yeah, that should be positive. So this negative and negative becomes positive, okay? And then I got the 0. So just check this one. I should get this 0 here too. All right. So that's a reduced row echelon form for A minus lambda I. Okay. So now you just write down the equation. So V1 is V1 minus 2 over 1 minus I V2. You're going to get that. All right. So, and then you're going to write down V1 in terms of V2 there. So that means eigenvector, when you write down V1, V2, is going to be V2 is just the 1. If you put it 1, you're going to have this guy. And now if I multiply by, if I think like a V2 is 1 minus I, that means you need to multiply this one by 1 minus I, and then it's going to get 2. All right. So again, I need to figure out what is P and what's a Q. P is a real part and Q is an imaginary part. So this is a real only, there's no imaginary. That's why it's 0 here on this side. And then I just can write down this. So I found my P and Q. Okay. After you find the P and Q, and then you're going to figure out what is X real and what X imaginary, right? Just plug in that number because your alpha is 0. That's why you're going to have 0. There's nothing there. That's going to be just a 1. Okay. That disappears. Okay. And then this and your eigenvector, this eigenvector just put together, and you can combine this one. So you can see that this multiply here, this multiply, there's nothing here. So you have in the first row, and then that's only this guy. But if you look at the second, multiply to 1 and then subtract one negative this one, right? And you got to get that. All right. And then what is same way you can do the imaginary part. You look at the formula there and just plug in there. After you do that, and your general solution is going to look like that. Okay, I'm going a little fast, but you can pause it here and look at the problem. Okay, so let me do one more problem, which has an initial condition, right? Initial value problem. Again, x prime equal to a times x, and then your x0, when t is 0, so your value is 5 over 4. Okay. Okay. Now again, a is this, so I need to find the eigenvalues. So A minus lambda I, find the determinant. So determinant equal to 0. So this, find the determinant, then set equal to 0, and again find the eigenvalues. Okay. After you can find the eigenvalue, then I'm going to find the eigenvector for this particular eigenvalue. You can choose either one. And then I'm going to write down, find the matrix A minus lambda I. So again, this one is 1. there's a 1 here, and then minus your lambda, and then same way a minus lambda I. And I'm going to change this one into, so first you 1 plus 1 is 2, you just rewrite that. I'm going to change into reduce row echelon form. Okay, so divide by 2 minus I, that makes it 1, right? And then you're going to have that. And then I can write down this one in the equation like that. So you can write down V1 equal to 5V2 over that. So let's write down, find the eigenvector. So V1, V2, and you can start with that. And then if I choose the bottom one is 2 minus I, that's going to be 5. I mean, it'll be easier if you're a little bit nice looking. I mean, this is okay too, but this is a little bit complicated, so I just changed into this form, okay? So you can easily find out P and Q. So that'll be a little bit easy work than if you use this one, okay? So I found the P and Q. Now plug it into real part, imaginary part, you plug in there, and it looks like that. So you pause this, you pause this one, write down everything, and make sure you get this. Imaginary part again, your beta is, in this case, is, what is a beta? So beta is 1, and alpha is -1, right? So that's why you have this e to the power negative, this alpha t, so that's why it's -t, right? And then the imaginary part, I found this one. Now again, your general solution is e to the power this one, c1, this is c1, and that same thing, c2 and this thing. So this is like a x real, and that's a x imaginary. So you can see up there the formula. Now, since we have this initial condition, so I'm going to put when t is 0, is going to be 5 and 4, the vector. And you're going to, when you put t is 0, you're going to have only this much left. You can come up with these equations, and then you can see c1 is 1 and c2 is -2. Plug in back to that equation. So I just plug in back here. It looks like this. Now you can combine here, right? Because there's no c1, c2, you can combine. So 5 cosine x minus 2, 5 times 2 is -10 sine t. And then this one and this, you combine, you like terms, you connect, you combine the like terms, and your final answer is going to be that. So that is my solution for your differential equation, x prime equal to, what's the matrix? 1, -5, 1, -5, 1, -3. So 1, -3, and then that's your x. And then your initial condition was 5 and 4. And the solution is going to be like that. Okay, that should be enough for this section to find the solution for the system of the first order differential equation if the eigenvalues are non-real, right? So if non-real, that means eigenvectors are non-real too, but we found the answer without using, so we changed that complex form to real form, right? Using this exponential function here, and then sine and cosine. All right, I'll stop here.